Now talking about cryptography, guys. What do you mean by cryptography? Crypto stands for secret and graphy stands for writing. So cryptography simply means secret writing. And it is said that, guys, cryptography was being used for the very first time by Julius Caesar. He used to send some cryptographic messages to his generals in wars. At that time, cryptography was very simple. With the evaluation of the technology, now we have very complicated cryptography techniques. And you will be amazed, guys, by listening that because of this cryptography, Germany lost the Second World War. Only because of it. Otherwise, today the world map would have been different. You know that Germany have created a very powerful encrypting machine with the name Enigma. There was a guy with the Allied forces with the name Alan Turing. Even in the BTech courses, guys, in the BTech computer science course, you'll be having a book with the name Alan Turing. So Alan Turing was the guy. See, the Enigma machine was so powerful. It used to create so you can say secure encrypting messages that it was impossible for the Allied forces to crack. Because of which the Allied forces were losing the war. But what happened is they contacted a guy with the name Alan Turing. And Alan Turing and his team, they designed a machine that was capable to decrypt the Enigma. And that was a turning point in World War II, because of which the Allied forces won the war and Germany lost. There is a movie based on it. If you want to see it, you can Google it. It's a very, very famous movie. All right. And that they have shown you that what actually happened. All right. Even nowadays, countries have, you can say, have a pact between them that they are not going to use any new kind of encryption. That's why they have a pact between them that whatever encryption method is being used in the world, they are going to use it. No organization, no country is allowed to use its own, you can say, encryption methods. All right. So depending upon this cryptography, the name is the imitation game. If you want to note it down, you can note it down. It's a very, very good movie. Imitation game. In that, they have shown you the exact power of cryptography. It's a movie based on the biography of Alan Turing. All right. Now, in cryptography, guys, we are going to cover these topics. That is, we are going to talk about encryption. We are going to talk about encoding. We are going to talk about hashing. We are going to talk about digital signatures. We are going to digital certificates. We are going to talk about PKI, inside which we'll be discussing about CA, RA, VA, and we are going to discuss about CRL. Also, we'll be discussing about cryptography attacks. All right, is it clear? Now, talking about encryption, guys. So what do you mean by encryption? Tell me. Always remember, in encryption we have two things that is known as algorithm and a key. Whereas algorithm is always public and key is always private. All right, but they will not be telling you the actual key of that algorithm. So key is always private. It is never shared. Now, guys, encryption. If I'll be writing the words, can anyone tell me what I have written? I have written hello, guys. All right. Now, encryption is a combination of, guys, three things. That is, we have ciphertext, we have algorithm and key, and we have. Is it clear? Now, guys, depending upon
ciphertext.
this one, cipher means what? Ciphertext means the text which is not readable by you. Which I have on plain text, I have applied certain kind of algorithm and key, and I have converted into the text that you're not able to read it. That is cipher. Okay. Now, depending upon your encryption, guys, we have two kind of encryption. That is symmetric encryption and asymmetric encryption. Now, what do you mean by symmetric encryption? One key is here, that is the public key. Whereas in asymmetric, we use two keys. All right, that is public and private key. Right? Now, guys, we'll be talking about both of them one by one. Talking about the first one, that is symmetric encryption. Now, guys, symmetric encryption, only one key is used. That's why the advantage is symmetric encryption is very fast. All right, it's very fast. But disadvantage of symmetric encryption is it's very weak. Now, why it is weak, I'm going to explain it to you. Now, let's suppose this is computer A and this is computer B. Computer A is in India and computer B is out of India. Right? This is computer A and this is computer B. Now, both of them are having their own set of public keys. So, I'm drawing it with different colors. Computer A is having its own set of public keys. I'm writing public key of A, and computer B is having own set of public keys. So, computer B will be having public key of B. Now, guys, if they want to communicate with each other, all right, first thing that will be shared is the public key of A will be shared with computer B. Public key of B will be shared with computer A. Now, if computer A wants to send a message to computer B, so what he will be doing, guys? Let's suppose he wants to send a message that is hi. So he will be writing the message that is hi. All right. Yeah, hello. And then he will be encrypting that message with the public key of B itself, to whom it's sending. All right. So he'll be encrypting the message with the public key of B, and then he'll be sharing the message to B. All right. Now, why it is fast? Because only one key is used. But what is the disadvantage, guys? Disadvantage is it's very unsecure. Now, why it is unsecure? The reason is they both are communicating over the internet. And again, repeating, internet is considered as weakest mode of communication, right? So anyone over this internet can snip the data and he can capture the packets that are traveling. So let's suppose if I'm a hacker over here, so if I will be sniffing, since public key of A is traveling over the network, I'll be having the public key of A. Is it or not? Also, public key of B is traveling over the network. So also I will be having public key of B, right? And the data that was being sent from computer A to B, it is also traveling over the network. So even I have the data also. Now, guys, this data is encrypted with any of these keys, either public key of A or public key of B. And to decrypt it, I will be requiring either public key of A or public key of B. And since I have both of them, I can apply either of these keys to decrypt the data. And as soon as I will be decrypting the data, I'll be able to view the contents, right? That is why symmetric encryption is very, very unsecure. Is it clear, guys? Then we have the next one, that is asymmetric. Now in asymmetric encryption, we have two set of keys. Can I remove this one, this figure? Now, guys, again, in asymmetric encryption, I told you we have two set of keys. That is public key of A and public key of B, and private key of A and private key of B. So I'm writing it over here. Now computer A and B, we are talking about asymmetric encryption. Okay. Now, in asymmetric encryption, we both the computers are having two set of keys. That is, it's having private key of A and it's having. Please make sure, please pay attention to the colors. I'm just writing different colors. Then we have public key of A. Similarly, computer B is having its own set of keys. It's having private key of B and public key of B. All right. Now again, guys, if they want to communicate with each other, they have to do what? The public key of A will be shared with B and the public key of B will be shared with, right? Now, asymmetric encryption is very secure, but it is very, very slow. That's why asymmetric encryption is practically not possible. All right, because it's very slow. So what we do is why it is slow and why it is secure. I'm going to explain it to you. Let's suppose computer A wants to send a message to computer B that is hi. Okay. He wants to send a message that is hi. Now, what computer A will be doing? He will be encrypting that message with the public key of B. And also he will be calculating the hash of this particular message that is hi. He will be calculating the hash of this message and then he will be encrypting that hash with the private key of itself. Okay, it will be encrypting it with the private key of itself. The hash, I'm writing it over here. It's the hash of the actual message. And before sending it, guys, again he will be encrypting the whole message with the public key of B. All right, and then this message is transferred to computer B. Whereas computer B is having its own private key. So only B is the person, is the computer which is able to decrypt this particular message. So he will be utilizing his private key B for decrypting the outer layer. Then he'll be decrypting this layer, that is in which he'll be getting high. Now he wants to make sure that whether the message he is receiving is legitimate or not. So he will be doing what, guys? He will be left with the hash that is encrypted with the private key. So always remember, anything that is encrypted with a private key can be decrypted with a public key. Now computer B is having public key of A or not? He's having, right? So he will be using the public key of A to decrypt the private key of A, and as soon as that, he will be getting the hash. He will be calculating the hash of this high, and then he will be doing what? He'll be calculating he will be comparing both the hashes, and if both the hashes matches, it means that the message is genuine. Is it clear? Why it is secure? The reason it is secure is, guys, this is the internet, right? Now let's suppose again a hacker is over here. Hacker is here. Now hacker have the access of the public key of A and public key of B, right? And also the message. But still, if he is having the message, guys, he cannot decrypt it. Why? Because this message can only be decrypted using the private key of B. All right, that's why asymmetric encryption is considered as secure encryption. All right, we are talking about encoding. So I have written a number over here. Can you please tell me what I have written? See, the thing is, guys, just to make your mind diverting, I just added this number, that is +9. All right, these kind of methods in forensics is known as anti-forensic technique. We have a particular term for it that is called obfuscators, obfuscation. All right, so I did what? I just added this number in front of these numbers just to deceive you. All right, now tell me what is it. Now do one thing, guys. Open your Google, open your browser. Now type ASCII over there, ASCII values, and map these numbers to those values. What word you will be getting? 72 stands for, in ASCII value 72 stands for, 69 stands for, 76 stands for, 76 stands for, and 79 stands for. So what I have written, guys? So guys, what is encoding? In encoding, we map. All right, we use the tables or predefined rules to encode the data. That is known as your encoding. We use what? We use predefined rules or mapping techniques to encode the data. Likewise, in this case, I used what? I use ASCII tables, right? To encode this hill. Now, in the same way, we have different kind of encoding methods, guys. We have ASCII, we have hexadecimal, we have binary encoding, we have UTF-8 encoding method, we have base 64 method, and many more. These are the encoding methods that we have. All right. Now, next is your hashing. Now, what is hashing, guys? Hashing is also known as one-way street, guys. All right. It is also known as one-way street because once you will be converting a given key into another value, you cannot revert it back. Likewise, for encryption, we have what? For encryption, we have decryption. For encoding, we have decoding. But for hashing, we don't have any kind of dehashing. All right. Is it clear? Next is, guys, in hashing, we have different kind of hashing algorithms. We have MD5, we have SHA-1, SHA-2, SHA-3. The latest one which is being used nowadays is SHA-256 and SHA-512. These are some examples of your hashing algorithms. All right. Then we have next, guys, that is your digital signatures. You know what digital signatures are? Yesterday I told you the hash value that is encrypted with the private key of the sender is known as digital signature. Now we have a term that is known as digital certificate. What is digital certificate, guys? This is my computer and this is, let's suppose, Jitin's computer, right? This computer A, that is mine, and this is computer B, that is Jitin's computer. Now I was having my own public key, right? I was having my own public key, and Jatin was having his own public key, that is public key of computer. Now, what was happening, guys, is to communicate with each other, we have to share our public key with each other, right? This is what we learned yesterday. Now, over the internet, if a hacker is sitting, he will be having the access of either my key or Jatin's key, right? So he can perform man in the middle attack, right? He can do what? He can compromise Jatin's key, and instead of Jatin's key, he can just share his key with me. So whatever I'll be doing, I will be encrypting the data and other things with his own. All right, this is a problem. So what we have decided now is we use digital certificates in case of these public keys. Now, what is a digital certificate, guys? How you get it? That is what we will be discussing in PKI. So I'm going to you can say define what are digital certificates now. Okay. So if you want to take the screenshot, please take the screenshot, and then I'll be removing the screen and I'll be going ahead with the PKI. Now, guys, we have the term that is PKI. So what is PKI, guys? PKI stands for PKI. PKI stands for Public Key Infrastructure. All right. Now, what is that, guys? In public key infrastructure, we have the components that is. Let's suppose you want a certificate for yourself. All right. For any website, guys, how you check whether the website is legitimate or not? How you check the authentication of the website? The first thing we check is HTTPS, right? Yeah. Whether it is HTTP and HTTPS. Second thing that we'll be checking is the log sign. What do you check in log sign, guys? We check for the certificates. All right, we check for the digital certificate. So here are the details of the certificate. Whom it was provided, by whom it was provided, the date it was provided, all right, the day it is going to expire. Apart from that, it is showing you the hash algorithm that is used. See, SHA-256, I gave you the example, right? Apart from that, it will be giving you the certification part. So this certificate has been provided by whom? By Google Trust Service, all right? And it is a well-known certification authority. So whenever you will be requiring a certificate for yourself, you will be using this PKI. Now I'll be explaining you this PKI. So this PKI has the following components. This is you as a user. Let's suppose you want a digital certificate for yourself. So you will be going to another authority. That authority will be guiding another authority to issue the certificate to you. Using that certificate, your certificate will be stored at other place, and then you will be utilizing that certificate. So I'm just marking the things over here. We have a user. That user is having his own private and public key. All right, it's having his private key of you, and we have public key of you. Then we have CA. Then we have BA. Apart from that, this is, let's suppose, another computer or a store. Now I'm writing the full forms over here, guys. RA stands for CA stands for VA stands for. All right. So these are the authorities. Now let's suppose over here, Sanoop wants to get a certificate, a digital certificate. So Sanoop will be doing what, guys? Using all his information, he will be approaching a registration authority. His private key, his public key, and rest of his authenticated information, he will be approaching registration. Now this registration authority will be doing what, guys? This registration authority will be verifying whether Sanoop is the authenticated person or not, or whether he is just spoofing the credentials. Once the registration authority will be verifying that, okay, it's Sanoop, he will be doing what? This registration authority will be contacting certification authority, right? So this RA will be asking the certification authority that, okay, this person is verified, I have authenticated him. Now please share a digital certificate, create a digital certificate for this person. Now the certification authority is also having two kind of keys within, that is public key of CA and private key of CA, right? Okay, but your digital certificate contains, guys, your digital certificate contains. So the CA will be allocating, will be giving you a digital certificate. Now the question is, what is your digital certificate? This is your digital certificate. So this digital certificate will be containing what? This digital certificate will be containing your information along with your public key that will be encrypted with the private key of certification authority. That is known as your digital certificate. Now, after providing you the digital certificate, guys, certification authority will be going to the validation authority and will be asking that, okay, I have provided this certificate to this user, please note it down. And this validation authority will be doing what? It will be storing the information in the database. Now, let's suppose after getting the certificate, obviously you'll be using your certificate somewhere, right? So let's suppose you want to use the certificate in a store, right, or with any other computer. Now, how this computer will get to know that whether you are giving the authenticated or legitimate certificate or not? So where it will be going? So this store will be, or this computer will be searching your certificate where? The validation authority. It will be asking that this is the certificate number, this is the user. Is he saying truth or not? This validation authority will be doing what? It will be checking its databases and it will be saying yes, the user is legitimate, and that is how you will be doing what? You will be having communication with the computer number 2. Is it clear how it works? Now guys, what happens is your computer, your devices already have a list of well-known certification authorities. If you'll be checking your computer, if you'll be checking your mobile phone, also over there you will be getting the list of very well-known certification authorities. All right, this is why we check the digital certificate. Now the next thing is we have CRL also. We have a term that is CRL. That is known as Certification Rejection List. All right, CRL. So what is CRL, guys? CRL stands for Certificate Rejection List. It was an older term. All right. Previously, PKI used to maintain the CRL. It means that whenever a certificate is expired or is compromised or is stolen, all right, in that case, certification authorities, the PKI, will be, you can say, including that certificate in CRL, that is certification rejection list. All the certificates that were facing the problem, they are included over here. But later on in your browsers, a protocol was used. All right, the protocol is known as OCSP. All right, that is Online Certificate Status Protocol. It runs in your browser, and this is the protocol that checks whether the URL, whether the URL domain you are using or you are opening, is it legitimate or not? Have you seen in many of the websites, when you open the website, your browser gives you the warning, the site is not secure? Yeah, that is the work of OCSP. All right. So this is about your cryptography. Now we'll be moving ahead and I'll be teaching you about your you can say cryptography attacks. So we have the following cryptography attacks. That is, we have known plain text, we have known cipher text, we have chosen plain text, and we have chosen cipher text. We have one more attack which is not given in your book, but again it's important. It's known as rubber hose attack. So what is known plain text? What do you mean by known plain text? See guys, again I'm asking, what is the most important thing in cryptography? Key, correct? Key is important, right? Because whatever algorithm you'll be using a key. Now over here, known plain text means as an attacker, you know the plain text of the message. So you will be doing what? In that plain text, you will be applying different kind of algorithms. All right. To do what? To create the same cipher text. And as soon as you'll be getting the same cipher text, you'll be getting the algorithm information and you'll be able to get the key also. That is the logic behind this known plain text. Similarly, we have known cipher text. So know what is known cipher text. In this, the cipher text is known to you. So you will be applying a decryption methods, all right, to change the cipher text into plain text, using which you will be getting the algorithm along with the key. Then we have chosen plain text and chosen cipher text. In this, as an attacker, you'll be choosing your own plain text or your cipher text depending upon the target, depending upon the victim, and then you will be applying algorithms and your, you can say, your key, so that you'll be getting the actual key of the algorithm. All right. Then we have the last one that is known as rubber hose attack. What is rubber hose attack? It's very famous one, and in exam also it is asked. And what do you mean by rubber hose attack? Rubber hose attack means obtaining the secret keys by torturing the victim. So I will be torturing you unless and until you will be revealing the secret keys to me. All right. So I think that out of all these attacks, rubber hose attack is the best one. Is it or not? Instead of wasting time, just torture the victim and he'll be revealing you. So that is rubber hose attack. All right. So this is what about your cryptography, guys. I hope you enjoyed it. So it's very useful again, guys, in whatever certification you'll be going in future, whether it be your, you can say, Intest Plus, whether it be your CYSA, whether it be your management level courses like you can say your CISO, CISA, CISM, ISO, or you can say CISSP. Over there also you'll be getting the topic that is cryptography. It's always included. If you'll be going for CEH also, that time also it will be included. So this cryptography and risk management, they are very, very important topics. All right.